Hello students, once again welcome to the lecture of Strength of Materials, second year BTech semester 3. In the last lecture we started with unit number 1, Stress and Strain of section 1. In that we studied in detail about the various engineering properties or mechanical properties of different materials like ductility, malleability, stiffness, elasticity, plasticity. Now let's move forward and go towards the next point, which is simple stress and strain and Hooke's law. Today we'll highlight these contents of this topic so that we get into detail about the various numericals we will going to solve in the coming lectures. So other part which we will cover is composite sections and normal stresses and strains. So first we need to know what is stress. Stress, the word till now you have heard in the concept of psychological word, but here stress has a different meaning in the word or in the subject strength of materials. So the force of resistance offered by a body against the deformation is called stress. So in simple words, whenever we apply some force on a body, it will offer some kind of resistance against this applied force. So this is nothing but stress. In other words, it is defined as the resisting force acting per unit cross-section area of the body. The body may be a circular, square, rectangular or any cross-section. Whatever amount of force we applied, there will be some kind of resistance offered by the body. It is also defined as the ratio of applied load to the cross-section area of the body. So whatever load we applied, if we divide it by the cross-section area, it may be length into breadth or length LBT, length, breadth or thickness. It will give us the stress. Now the SI unit of stress which we usually measure is Newton per meter square. Now to understand the concept of stress in a much better way, we'll see through a diagrammatic representation. Now consider a body or a member or a rod having a length L. It is subjected to axial tensile load or axial load P. Now when the load or axial load P is pulling the rod in both the direction, some kind of internal force or internal resisting force will be created by the body inside the body. Means it will resist the deformation, resist the change in dimensions of the body which is being carried due to the applied load, which is denoted by R. R means the resisting force and P means the applied load. Now, how will we denote it in a much technological terms? Sigma is equal to resisting force upon cross section area. Here the term sigma we will be denoting as stress. So sigma is equal to R by A in symbolic terms, but resisting force is equal to the applied load. Now the amount of applied load we exerted on the body, the same amount of resistance will be offered by the body. So applied load P is equal to resisting force. So finally stress is also equal to load upon area means P upon A. Now as we have got two equations of sigma, that is sigma is equal to P by A and sigma is equal to R by A. So sigma can be defined as in terms force or load in newtons divided by cross section area in meter square. Now SI unit of stress as we already studied in Newton per meter square. Here in the equation sigma is the term which is known as stress in Pascal. Pascal is unit, also expressed as Newton per meter square or Newton per mm square. Now why it is written as Newton per mm square? Because ahead in all the problems which we will be solving, most of it will be based on the units millimeter means mm. So final answer of stress will get in the terms of Newton per mm square. But the standard unit of stress is Newton per meter square in standard cases. R is the resisting force induced in the body which will be in terms of Newton or kilonewton. P is the applied load on the body also expressed as Newton or kilonewton, and A is the cross section area of the body in mm square or meter square. Whatever unit is given accordingly we have to use it in the calculation purpose. Now next part is how will we explain this in the terms of an example. Now a bar has a dimensions as given in the figure below and is subjected to an axial pull of 25 kN. Find the stress in the bar. So a bar is given in this form having length 120 mm small l, thickness equal to 5 mm, and a tensile load means P of 25 kN is acting in the axial directions in the opposite sides of the bar, means it is pulling the bar outwards. Now we have to find out the stress. What is the given data we have to write down is the cross section area means L into B, 120 into 5 equals to 600 mm square. L into B gives us the cross section area. Load P is equal to 25 kilonewton. Now it is in kilonewton. We'll convert it into Newton, that is 25 into 10 to 3 Newton, because 1 kilonewton equals to 1000 Newton means 10 to 3 Newton. So we have to find out stress means sigma, so we denote it by question mark. So formula for sigma is P by A. So we'll calculate P, we'll put it as 25 into 10 to 3. A we calculate it as 600. And now numerator has a unit of Newton and denominator has a unit of mm square. As the area we calculated was L was in mm, B was in mm, so area is in mm square. So final sigma value we get after calculations is 41.60 Newton per mm square. So in this way we have to find out the stress in all the numericals will be solving in this unit, and similarly other terms we have to find out in the question. So you have to write down the given data properly, as well as write to find out find out term properly, the formula properly, and finally you have to bold or underline the answer you have found out. Now next is types of stresses. So these are the types of stresses we are going to consider. Let's see the tree diagram. The stress is mainly divided into three types: direct stress or simple stress, indirect stress, and combined stress. In direct stress or simple stress, there are two categories: shear stress and normal stress. Normal stress is also categorized into two parts: tensile and compressive stress, which will be looked in this lecture. The other parts, torsional stresses and bending stresses, are considered in other unit of the strength of materials, and combined stresses will be studied in the next SOM 2. So, what is tensile stress? Whenever two equal opposite pulls applied to a body and increases length of the body is called as tensile stress. It is also considered as a positive stress, means it is considered as a positive value. As a result of tensile stress, the cross-sectional area of the body gets reduced. Means whenever tensile load is applied on the body, due to increase in the length of the body, the other dimensions of the body are reduced. Example, when a rod or a wire is stretched by pulling it with equal and opposite forces in the outward direction at both the ends, its dimension changes. Now let's see in the form of figure. A body is shown having a length L and a tensile load P is applied in both the directions in the opposite way axially. Now, after the load is applied in the axial direction in opposite sides, there will be change in length of the body, means the length of the body will be increased, but the thickness will be reduced and dimensions will change. So this is known as change in length, that is delta L. So whenever an axial tensile load or axial load of pull is applied on the body in the opposite direction, there will be change in length of the body, which is known as delta L, which is considered as a positive value. Again, compressive stress. If the deforming force or applied force results in the decrease in the object's length, then the resulting stress is termed as compressive stress. This is totally opposite of the term tensile stress. It is considered as negative stress. Rod or wire is compressed or squeezed by pushing it with equal and opposite forces in the inward direction. At both the ends, it will be compressed. So, consider a rod or a bar of length L and having applied a compressive load, that is push load on both the sides, that is P. Now due to this load, the bar's cross sectional area will decrease and dimensions will increase, which is also resulting in the change in length, which is known as delta L. In the early case, the length was increased but the other dimensions decreased. In this case, length was decreased and the thickness was increased. So these are the changes in dimensions occur due to tensile or compressive stress. So just like stress, the most and next important part is strain. So it is a measure of deformation produced in a member due to the loads acting on it. So strain in simple words is whatever is the deformation produced in the member due to the applied loads or any kind of loads applied on the member is defined as strain. It is also defined as the ratio of change in length to the original length of the member. As you already studied in the previous examples, that whenever a load of tensile or compressive is applied on the body, there are changes in the dimensions of the body. So this change in dimensions to the original dimensions, the ratio of it is defined as strain. So example, consider a rod of length L having the dimensions length L, and whenever a load is applied on both the sides, that is load P, there will be strain induced. So because of that, there will be change in dimensions. So this dimension is shown by dotted lines, and this change in length or deformation is defined as delta L. So original length of the bar was L, means small l, and after the tensile load was applied, there was increase in the dimensions of the bar, which is denoted by dotted line and dimension as delta L. Now the formula to calculate the strain is given by epsilon equals to E equals to delta L upon L. Here the term epsilon is used to denote strain, or also indicated by small e. Strain has no unit. The other term delta L is the change in length of the body, which is in the terms of meter or centimeter or mm. L equals to original length of the body, which will be again in terms of meter or centimeter or mm. So whenever you will be solving the problem on strain, you have to keep the terms of L and delta L same. Means if you consider the length as meter or mm, you have to consider the delta L value also in terms of meter or mm. Both the values should have same units. So strain is a term which is a dimensionless quantity. Now how it becomes a dimensionless quantity? Now consider in the formula delta L is in mm and length is in mm, as both the units we have to keep the same. So mm gets cancelled and strain becomes a dimensionless quantity. Now the next term is tensile strain. It is the ratio of increase in length of the member to the original length of the member. It is considered as a positive strain. So the formula to calculate tensile strain is, it is a ratio of increase in length to the original length of the member. Again, compressive strain. It is the ratio of decrease in length of the member to the original length of the member. It is considered as negative strain. So the formula for it is compressive strain is equal to, it is decrease in length upon original length. So the last term is Hooke's law. Whenever a material is loaded within the proportional limit or elastic limit, the stress produced is directly proportional to the strain. So see the graph, on the y-axis it is stress, on the x-axis it is strain, and the line is shown as a straight line. Means it is a proportional line both to stress as well as strain. Stress is denoted by sigma and strain as epsilon. Means if you draw the slope at anywhere on the line, it will be proportional to each other. It is defined as, or denoted by stress sigma upon strain equals to constant, which is denoted by capital E. Now what is this term capital E? E is known as Young's modulus or modulus of elasticity, and it has a unit, SI unit of Newton per mm square. So this constant is being defined as E, which is here denoted by Young's modulus or modulus of elasticity. So let's take a quick review of today's lecture. What is stress and its unit? Define tensile stress and compressive stress. What is strain and its unit? Define tensile strain and compressive strain, and define Hooke's law. So these are some of the questions you will be asked in the oral exam of strength of materials. Also it can come for theory questions in the university paper. So you have to go through these points, go through this lecture once again to answer these questions in a single line much quickly. Thank you.